All right, so I wanted to give you a few homework hints to help you with what you're doing tonight. So we have a 10-gram bullet, and let's be clear. If we convert that to kilograms, that's going to be 0.010 kilograms. Now, the barrel length, that's a distance s. We have a force F, and we want to know what speed the bullet would reach. So a couple of hints just to kind of help you think about energy stuff. When you see an IB problem that has a force, a distance like this, and you want to know a final speed, well, there's several approaches we could take. But one approach when we're dealing with work and energy is you know that this is some kind of a work problem. Now, the general formula for work is F times S times the cosine of the angle between F and S. If they don't give you an angle, you know that you don't need to worry about this. So, okay, not important. So what we can say is that the work is simply F times S. Now, there's another important theorem from the reading. Okay, we were going to discuss it in class, but we didn't get a chance to, which is that the work done on an object is actually the change in its kinetic energy. So in other words, that's 1/2 mv squared minus 1/2 mu squared. So that's actually a really good hint to get you set up for problem number 1. Okay. Now here, problem number 2, you got a mass, you got a speed. Come on, you can do this one. Okay. So let's not draw an energy bar graph of the situation. Let's instead do the following. So again, work is the change in kinetic energy. And we know the car comes to a stop. So that means V is 0. We've got an M. And we know that this is U, the initial speed. So we know the work done, the force times the displacement, once again, is 1/2 mv squared minus 1/2 mu squared. And I do want to see you try to set that up. Okay. All right. Now for number 3. I want you to use 1 and 2 as hints to give you an idea of what it is that you need to do. So use 1 and 2 will help you. Okay? So that should get you started on 1, 2, and 3. Now, for number 4, let's see. There's a lot to this problem here. So Pizzeria, I didn't make these names up, works at this pizza parlor. He's got to fill drinks. Now, he's going to basically do this thing where there is this is a 2-part question. So first, I'm going to have you do the following. Number 1, find, so number 1 for this one, draw me a free body diagram. Number 2, find the friction force. Okay, remember the coefficient of friction, that's mu. And let's remember that friction is mu times the reaction force. And then finally, okay, get F net. What does F net mean? okay? And then you're going to use this. You will, in fact, then use F net times S is 1/2 mv squared minus 1/2 mu squared. So that's number 4. Okay. Now for number 5, okay. So we have a simple situation where we have a volleyball that is here, okay? It has a height and it has a speed of 1.06 meters per second, okay? And then here's the deal. It hits the ground and it has an extra energy of 9.89 joules in addition to what it started with. So this will be a conservation of energy question, but you'll need to do a little bit more with it. Okay. Now, number 6, I'll give you one hint. We've got a kid on a slide. Okay. V is 0. H is greater than 0. And then here we have V is not equal to 0. H equals 0. And there's some dissipated energy. And you will use conservation of energy for number 6. Okay. Same with this part here. Number 7 we did in class. Now number 8. Number 8, okay, the situation is like this. Okay, I'll say it like this. So this is no friction, and I have the spring that's compressed, okay, and this is going to be a conservation of energy. Assume that H equals 0 and that there's no friction. Now here, we're going to change the problem around. So we have all E elastic, and it becomes all E gravitational. For number 9, there we need the power equation. Power is going to be work over time, and in this case the work is going to be mgh. Now this one here, it's a super tough question, so I want a free body diagram to get us started. So those are your hints for the homework. I at least want these in your notes. I'm going to say this, though. I do want to see numerical answers for questions 1, 2, and 3.